Okay, today is 1.2.4, and it is about odd versus even functions. I'm going to give you a really quick explanation. Odd functions have point symmetry. That is terrible. I'm going to try again. Odd functions have point symmetry, like for instance this one has point symmetry, meaning through the origin. If I take a spot here, go through the origin, on the other side there's another spot like it. Okay, so this point, which would have been, let's say, 2, 3, turns into -2, -3. Notice it's the same function except with a negative. Okay, even functions, they have line symmetry. So like, for instance, the old classic parabola. If I take a line down the middle, a point over here goes right over here, and this used to be 2, 5. Well, it turns into -2, 5. Notice, again, a negative involved, but a negative is only on one part of it. Does that make sense? All right. Notice that the x here changed to negative. Here, both the x and the y changed to negative. Maybe you'll see a correlation then in the next thing that I show you, which is where you take the equation of it. You have a function's equation. If you don't have a picture for it, you have the equation. Then you have to do something a little more complicated to tell if it's even or if it's odd. This next thing is worthy of you writing down. Make sure you put a star by it. This is the definition of even and odd. If f of negative x is equal to f of x, then the function is even. You'll understand more what this means in a second. For right now, just write it down. To get how the one function and the other function are only different by the fact that the x is the opposite. Think about that on that point symmetry I was showing you. If you've got the parabola here, and you got this is at, let's say, 1, 1, and this spot over here is at -1, 1, do you get how the x is the opposite? Okay, so it's kind of related. Now, how about if they're odd? If they're odd, then f of negative x will equal the opposite of f of x. And that's if it's odd. All right, so if you're going to tell if a function is even or if it's odd, the first thing you got to figure out is f of negative x. What does that mean? That means I'm taking a function and I'm sticking in negative x into the function. So that's the first thing I should practice with you, is if I have a function like this, x squared plus 2, normally you don't have the parentheses there, do you? I'm just going to remind you what you should be thinking. Every time you see a variable, I want you to think that's an empty parenthesis, waiting for something to stick in there. Okay? So on this one, I would have y equals empty parenthesis squared plus 2. And what am I supposed to stick in? If I'm going to figure out f of negative x, remember y is like f of x, right? If I want to figure out f of negative x, then I need to, instead of like, if I want to stick in 2 in the function, I'd stick the 2 in here. If I want to stick in f of negative x, I want to stick a negative x into the function. I put a negative x right there. That's really not too hard to figure out. F of negative x then would be negative x squared, which means negative x times negative x, which means what? Is it x squared? Or is it negative x squared for an answer? Will squaring this negative make it go away? Yes, it will. So therefore, it becomes x squared plus 2. Now, what did I just figure out? I figured out that f of x was x squared plus 2. Something? Yep. Yes, it's a lot like that. Yes, very good. Okay, this is me figuring out I'm sticking a negative into this function. I stuck a negative into this function, and what happened? It came out exactly the same as the original function. Do you get what I've written here really shows that f of x and f of negative x are the same as each other. And that's the definition of even. The definition of even is that f of x should be equal to negative, or excuse me, f of negative x. Sorry, I wrote it wrong. F of negative x should be equal to f of x. So if you stick in a negative into the function, and it comes out the same as it was in the first place, then you had an even function. So here's how you'd actually show your work. I've written it out. I've gotten to this point. I now notice that this and that are equal to each other. I can just say even. And I'd like you to use 3 dots in a triangle. Do you know what that means? That's the shortcut for the word therefore. So I have just made a little proof here. I started with a function, I stuck in negative x into the function, and when I did that, the answer came out the same as the original answer, and I could say, therefore, it's even. The triangle's a little off. There we go. Therefore, it's even. Okay, what if I had stuck it in there and it hadn't worked? Then I would know it was not even. Let's do one like that. Here's my new function. F of x is equal to x minus 2 squared. Actually, no, that's going to be too complicated. Sorry. I'm going to do x to the third minus 1. There we go. Okay, there's my original function. First thing you do is always, whether you're testing the even rule or the odd rule, here's both rules. Here's the even rule and the odd rule. What do you start with both times? You stick in a negative x. Okay? So go back to this one. Everybody stick in a negative x and figure out what f of negative x is. What is f of negative x? Negative x times negative x times negative x makes negative x cubed minus 1. The original problem was x cubed minus 1. Is this the same thing? No. Therefore, not even. But the problem is, what? The problem is it's not just automatically odd then. Because as you know from imagining the, stop interrupting, raise your hand if you want to ask a question, I'll call on you if you do that. We know from the pictures, not everything has symmetry, right? That's actually kind of a rare thing to have a picture that's got perfect symmetry down the middle or perfect symmetry the other way. Most functions do not have odd or even symmetry. Most functions are neither. So I've just checked this one for whether or not it's even. It's not even. So now I'm going to move on and check and see if it's odd. So the next thing I do, and this is important here, is I factor out a negative 1 from this function. Do you get both of them have a negative in it? I can factor out a negative 1 and then put what's left. X cubed plus 1. Okay? Now, this is the trickier part to understand. But if the rule for odd things is that if you have f of negative x, that it will equal negative f of x. Do you get how, by factoring out a negative 1 here, I have the negative? And that means that if this is the same as this, then I would have negative, and this would be f of x. Is this the same as this? No. And therefore, I just proved, by factoring out that negative 1, and then this not being f of x, again, I now can say, therefore, it's not odd. And as soon as you said there, it's not even and not odd, then you can say, therefore, it is neither. That function I just did there is a neither. See, a lot of people think, oh, it's got an x cubed in it, so it must be odd. Mm-mm. Just because it got an x cubed in it does not mean it's an odd function. Doesn't mean it has perfect symmetry. Why not? Because if I move it like this, which is the x cubed function, which looks like this, and then I move it down 1, all of a sudden it doesn't have perfect symmetry through the origin anymore. So it's not odd. Okay, I'll give you another function. And on this one, I want you to tell me if this function right here, 1 over x, is that function even or odd or neither? First step is always to figure out what f of negative x is and see if you can do this. All right, so f of negative x means I stick in negative x. 1 over negative x. Isn't that pretty much it? Okay. Remember, if this equals this, the thing's even. If the thing is even. Does this equal this? No. So therefore, not even. In fact, I should be writing that off to the side because it gives me not even. That way I can just keep this algebra flowing down here. Now, do you remember what you're supposed to do? Factor out what? Yes? Factor out a negative 1. Negative 1 comes out front. And then if I factor out a negative 1, be careful on this now. Is that right? Did I factor out the negative 1 correctly? Yes, I did. Because when I multiply this back in, this times this, it would equal 1 over negative x. Because does that negative being on the bottom really matter? The negative could be on the top, the negative could be in the middle, it doesn't really matter. Okay, so now I factored out the negative 1. Now, is that the same as that? Yes, it is. Therefore, we have just proven that this is odd. You're supposed to have a negative 1 there. Remember, the rule for this is that f of negative x should be equal to negative of f of x. Do you get how that's the same as negative 1 times f of x? That's the rule for odd things, is that if you put in negative x, you'll get the same as the opposite of f of x, a negative 1 in front of the f of x. See, here is the negative 1 in front of the f of x. So it's odd. Now I want you to think about the picture of it. Do you remember what 1 over x looks like? It's the fraction function. It looks like this. Remember this one? And does it have odd symmetry? It does, because if you go right through the origin, boop, there's a point there. Take this one, go through the origin, boop, there's a point there. See what I mean? It's got odd symmetry, so it makes sense that it would be odd. Okay, let's give you another one. 2x squared plus 3. Is that even? Is it odd? Is it neither? Try to figure it out. First step, always start with f of negative x. Bada bing, bada boom. I bet you're probably close to done already. Duke, what'd you get when you stuck in the negative x? This is still squared, isn't it? What does that mean? That means that f of negative x comes out exactly the same as f of x. What does that mean? Therefore, even. Raise your hand if you had that. Okay, good. Catching on? Let's do another odd one and see if it comes out odd, or if the way I shift it or stretch it or whatever makes it not come out odd. See if x cubed plus 2x is even or odd or neither. In a second, I'm going to have you show the kid sitting next to you. So get the first step done. Just figure out f of negative x. Pause for a second while I assign you to little groups. Okay, there's me dropping in a negative x into the empty spot. I'll go back and here. That's where you start. You drop in negative x, and then you get, that one comes out negative, and that one comes out to be plus a negative 2x, but you should really say minus 2x, right? There we go. So what do we figure out? We figured out that this thing is not coming out even, because here's my answer for f of x, and here's my answer for f of negative x, and they are not the same, are they? So therefore not even. Put that off to the side if you haven't already. Then what do we do? Factor out a negative 1. And what do you got left? X cubed plus 2x. Is this f of x? Because remember, if it's negative f of x, then it must be odd. And that is f of x. Cool. So we just proved, therefore, it's odd. Raise your hand if you feel like you get this. Okay, good. Then you should start your homework. It's got a lot of problems. I am going to have you skip a few, but that's all I have for the video for today.